Hello, doctor. My name is Kee Zhi Ting, matrix number 24006070. Today, I'll discuss the crucial role of second-order circuits in EEG system, which measure the brain's electrical activity. Let's start by understanding what second-order circuits are. A second-order electrical circuit involves two energy storage elements, typically capacitors and inductors, and is characterized by its response to an input signal. These circuits are called second order because they have two reactive components, which mean they can be more selective in filtering signals than first order circuits, which only have one reactive component. Second order circuits are often used for filtering purposes in signal processing. They can have more precise control over the frequencies they allow to pass through or suppress, which makes them ideal for application where distinguishing between different frequency bands is important. Now, let's dive into the application of second-order circuits in EEG system. EEG is a technique used to measure the brain's electrical activity by detecting the tiny electrical signals produced by neurons firing in the brain. This activity is captured by electrodes placed on the scalp. However, the EEG are often mixed with noise from various sources such as electrical interference, muscle activity, and even movement artifacts, which can make the signal difficult to analyze. This is where filters, especially second-order filters, become incredibly useful. Now you may wonder, why specifically second-order circuits for EEG? A second-order bandpass filter has a sharper roll-off than a first-order filter, meaning it can reject unwanted frequencies more effectively. This is particularly important in EEG, where a precise frequency filtering is required to isolate brain wave activity from noises. For instance, let's consider that we want to isolate alpha waves from an EEG signal. A second-order bandpass filter designed for this range will allow alpha waves to pass while significantly attenuating both lower frequency like delta wave and higher frequency like beta waves, and even noise like power line interference. This ensures that the brain's electrical activity of interest is captured accurately. So, how does this second-order circuit work in practice? A second-order bandpass filter typically involves components like capacitors and resistor, or sometimes inductor. These components are arranged in such a way that the circuit resonates at a particular frequency. The resonance is tuned to pass the desired frequency range and reject frequencies both above and below this range. For example, if you want to design a filter to pass frequency between 8 Hz and 13 Hz for the alpha band, you can choose values for the resistor and capacitors that set the center frequency of the bandpass filter to the middle of the range, about 10.5 Hz. The quality factor of the filter determines the sharpness of the pass band. A higher Q value results in a narrower pass band, which is crucial for selectively isolating the desired EEG signal without including nearby noises. Second-order circuits in EEG system are essential for analyzing various brain states. For example, alpha waves are commonly associated with relaxed wakefulness, while beta waves are associated with active thinking and concentration. Theta waves are often seen in drowsiness or light sleep. In clinical application, second-order bandpass filter help isolate these specific brainwave frequencies, which can then be used to monitor conditions like epilepsy, where certain abnormal brainwave pattern need to be detected. Filters also help during sleep studies, where different frequency bands indicate stages of sleep. By filtering out noise and enhancing the relevant brainwave activity, second-order circuits ensure that the EEG signals are clean and precise, making the interpretation of the data more accurate for both diagnostic and research purposes. In summary, second-order circuit plays a critical role in EEG system by enabling the accurate detection and analysis of specific brainwave frequency. They are most commonly used in the form of bandpass filter, which allow specific frequency ranges like alpha, beta, and theta waves to pass through while filtering out unwanted noise and irrelevant frequency. The precision and selectivity of second-order circuits makes them indispensable in ensuring that EEG systems provide reliable, clear, and meaningful data for clinical and research application. Thank you.